Hi guys, so today we're going to be doing surface area of cylinders. Surface area of cylinders and surface area of prisms are very similar. So if you got one, you really have the other. Okay. So before we get started with our first example, let's look at some definitions here. Okay. So you know what a cylinder is, right? This is a cylinder. Okay. The axis of the cylinder is a segment with endpoints that are centers of the circular bases. So it just connects center of one base to the center of the other base. That's your axis. Okay. If the axis is also the altitude or the height of the cylinder, then the cylinder is known as a right cylinder. Okay. So again, we can have oblique cylinders. If you look at the page before, it has examples of oblique prisms and oblique cylinders. Okay. But note here, because this axis is also the height, that's why it's a right cylinder, versus the axis for the oblique cylinder is slanted here, and therefore it cannot be the height. Okay. The net of a cylinder, so basically if I cut the cylinder and then laid it out flat, looks something like this. It's composed of two congruent circles and a rectangle. Okay. And the area of the rectangle is the lateral area, okay? And so if you can imagine this, this is the part that loops around the circle. So this length here is actually the circumference of the base, which we know as 2 pi r. And so that's why the lateral area of a right cylinder is 2 pi rh, okay? Which is similar to your prism. It's just instead of 2 pi rh, it's perimeter, right? Because the word for perimeter, when we're talking for circles, is circumference. So it's essentially circumference times your height, and in prisms, it's perimeter times your height. So that makes it nice and easy if you choose to memorize the formula. Okay, so let's start with our first example. Okay, so an office has recycling barrels that are cylindrical, so in the shape of a cylinder, with cardboard sides, and then plastic lids and bases. So plastic bottom and top, but the other parts are cardboard. Okay. So each barrel is 3 feet tall, and the diameter is 30 inches. So just so we could visualize it a little, get the pen. Here's my cylinder, not to scale. Okay. Okay, this is 3 feet tall, and the diameter, so here to here, is 30 inches. Okay, we want to know how many square feet of cardboard are used. And so since cardboard is just the wraparound, right, it doesn't include this top or the bottom, we are looking for the lateral area of a cylinder. Okay, so essentially, if we cut it and rolled it open, right, so we're going to first convert this into inches, so that way we're talking about the same measurements, because this is inches and this is feet. So 3 feet is 36 inches, because there's 12 inches in a foot. Okay, so here, essentially when we cut it, this wraparound here, this is the circumference, right? And this is the height of that rectangle. So the circumference we know is 2 pi rh, so the circumference is 2 pi r. Here, if the diameter is 30, that means the radius is 15. Okay. And then the height of this is 36. Okay. So essentially, what we're doing is we're cutting it open, and we're just doing this part here, right? So this is the wraparound that goes around the circle, and this is how tall that cylinder is. Okay. Okay, so then I'm going to type it into my calculator. So 2 times 15 times 36. This gives me 1,080 pi. Inches times inches is square inches. So this is the exact lateral area. Okay. But then if we want to... we want to change it back to feet. So before I do anything, I'm going to actually change it back to feet. Okay. So this is the inches. What I'm going to do is I'm going to change it back from inches to feet. So there's 12 inches in a foot. And I'm going to do it again because it's inches squared, so I need to get rid of the inches twice. It's 1 foot. Inches squared cancel out with the divide by inches and the divide by inches. So now I just need to do 1080 divided by 12 divided by 12 again, and times pi. Okay. And then that gives me approximately 23.6 square feet. And there you go. Okay. So why don't you try CYP1, and then once you're done, come check your answer. Okay, you should have gotten 263.9 square inches. If you got that right, you can move on to the next example. If not, here is your explanation. Okay, so Matt is buying new tire rims that are 14 inches in diameter and 6 inches wide. So essentially, if you think about your tire, it's kind of like this. Right, this part is 14, and then this part here is the 6. Okay. So if the diameter is 14, that means the radius is 7, okay? And so we want the wraparound here, right? So then that's the circumference times how long this is. So circumference is 2 pi r, so 2 pi 7 inches times 6 inches for this part. And then you get 84 pi square inches. That's the exact lateral area. And then it is approximately, rounded to 1 decimal, 263.9 square inches. Okay, so that was lateral area. That's just the wraparound part. Okay, surface area will also include the base, which is why here in the formula you see now it includes 2, and this is our B, capital B, area base, right? In this case, our basis is circle, so that's why it's pi r squared, right? So note, it's very similar to our formula for prism. It's just this in our prism is perimeter, right, which for circles is known as circumference. That's our circumference times height. And then this pi r squared is our base, right? It's just that in this case, our bases for cylinders are circles, okay? Okay, so let's take a look at example 2, okay? So example 2 asks us to find the surface area of the cylinder, okay? So we have the wraparound part, which is our lateral area, as well as our 2 circles, top and bottom. Okay. So here, the wraparound part, this is 2 pi r, so 2 pi. A radius in this case is 8.3 feet, and then the height here is 6.6. Right. So that's the wraparound part. If I cut it open, it's a rectangle, where the length is that circumference, and then the width or the height is the height of the cylinder. Okay. Then we also want our circles, the top and bottom, and since they're 2 and they're exactly the same, I can just multiply by 2 instead of adding it twice. And then that's pi, radius is 8.3 feet, and then I'm going to square it. Okay? Okay, so then I'm going to type that into my calculator. 2 times 8.3 times 6.6. That gives me 109.58. Sorry, I just ended up calculating it all, and then you should get 777.0 square feet. Right? So it's just 2 times 8.3 times 6.6 is 109.56 pi, and then 8.3 squared times pi, 8.3 squared times 2 would be 137.78 pi. So if I have this many pi plus this many pi, I have 247.34 pi's, and then actually multiplied the pi in, and that gave me 777.0. Okay. So why don't you try CYP2A? Instead of giving you a picture, it just tells you what the diameter and the height of the cylinder is, and then once you're done, come check your answer. Okay, you should have gotten about 263.9 squared centimeters. If you got that right, you can move on to our last example. If not, here is your explanation. Okay, so I drew the cylinder just because it helps to visualize it at times. Okay, so the diameter here is 6 centimeters, which means the radius is 3, right, because it's half of that, and the height is 11. Okay, so the surface area, I want the wraparound, so that's the circumference times this. That will give you the rectangle if it's unfolded. So that's why it's 2 pi, radius is 3 centimeters times 11 centimeters. And then it's not just lateral area, but it also wants the base, right? Because it's surface area. So the two bases are circles. They're the same, so that's why it's 2. And then area of circle is pi r squared, so pi 3 centimeters, and then squared. Okay. Then I just simplify it and then rounded it to 1 decimal place, so that's 263.9 square centimeters. Okay, so we're on the last example here. Okay. So here we want to find the radius of the base of a right cylinder if the surface area is 128 pi squared centimeters and the height is 12 centimeters. Okay, so my surface area I know is 128 pi square centimeters. Okay, so what goes into surface area? Okay, so the wraparound, right, is the circumference and the height, so that's 2 pi r times the height, which is 12 centimeters. Okay. Plus, okay, the bases. There's 2 bases and they're the same. They're circles. Area of the circle is pi r squared. Okay, and there you go. Okay. So now I'm going to simplify. So this is 128 pi square centimeters equals 24 pi times radius, because 2 times 12 is 24, so 25 pi radius plus 2 pi radius squares. Okay. So note that each of these are divisible by 2 pi, so I'm going to do that by making it a little bit simpler. So I'm going to divide it both sides by 2 pi just to simplify it a little bit more. So 128 pi divided by 2 pi is now 64 square centimeters. 24 divided by 2 is 12. And then the pi and the pi cancel. And then 2 pi r squared divided by 2 pi is just r squared. There you go. Then I'm going to solve this. So it's a quadratic, so I'm going to move everything to the same side, r squared plus 12r. I just rearrange these. I can do that because of the commutative property. And then subtract 64 centimeters squared, which right now, because the centimeters might be confusing, let's leave that out. Okay. Then I'm going to factor. Okay. So 2 things that multiply to be negative 64, but add up to 12, that's 16 and 4. And the 16 is going to be positive because it's a plus 12r. Okay. Here, r could equal negative 16 or 4, but because you can't have a negative radius, that just means my radius is 4 centimeters. And there you go. So why don't you try CYP3, and then once you're done, come check your answer. Okay, you should have gotten that the diameter is 16 inches. If you got that right, you can get started on your homework. If not, here is your explanation. Okay, so we know the surface area is 464 pi. How do we get surface area? It's 2 pi r times the height, which I know is 21, plus the 2 of our bases, so 2 pi r squared. Okay. All of the terms here are divisible by 2 pi, so just to make the numbers a little bit smaller, I divided everything by 2 pi. 464 divided by 2 is 232. Pi divided by pi is just 1. So 232 times 1, 232. Okay. 2 pi divided by 2 pi is 1, so then it just leaves me with 21r. Okay. 2 pi divided by 2 pi is just 1, so 1r squared. Okay. Then, since this is a quadratic, I did it by solving for a quadratic by moving everything to the same side. I rewrote it in standard form, r squared plus 21r, and then subtracting the 232. Okay. So what multiplies to negative 232 but adds up to 21? It's 29 and negative 8. Okay. Since you can't have a negative radius, I'm only going to take the r equals 8. Okay. However, since the direction said to find the diameter, if radius is 8 inches, that means diameter is 16 inches. Okay. So that's it for today. Have a great rest of the day. Bye, guys.